Hello, everybody. My name is Karin Haynes. I'm from Swansea University. I'd like to talk about the workshop. The title is Light Sources for Applications in Life Science. It will be in February 25th, 2016 at the Swansea University in Wales, United Kingdom. The next slide. Okay, what we have here, we have several facilities that work with healthcare. We have the ILS, that is the Institute of Life Science. There are two buildings there. We got also the hospital in the back. You can see the cycle is the NHS hospital, so we interact with the partition there. So we have people from College Engineering, College of Biology and Medicine that can interact directly with the doctors and also to have access to samples and patients. We have the same age, that is another facility where we have not only opticals but also semiconductors and other large equipment. And we recently started a new campus. We call it Bay Campus. We have another campus being developed. It's in the bottom of the page where we now located. We just moved it here the last month, where we're going to have other facilities for the photonics, optics, and also biomedic. We transfer here. The next page we have the big campus is still in development. The building is very much in the detail where we have the labs. So the idea of creating this new campus is we need to expand the engineering, continue growing, so we move engineering with management. Reasons was to create a more relationship with the companies, with the industries, local and international. We have local industry support for advanced manufacturing program, drug initiative, A4B, that's a Welsh government program, and financing for bringing biomedical companies to open branches in Wales. Next one. Just something what we are doing is facilitating capability. We have listed, as I showed before, we have labs and facilities in different parts of the campus of this university. So one is the test of laser and light sources and optical biomedical components. Customize the laser source, I talk a little bit more after. Optical sensing and probe. It is a spectroscopy facility, ultraviolet, infrared, femtosecond pulses, and watts average level, so high power. Plus analyze facility. Connection with the hospital, the single hospital, that is the NHS hospital shown in the map before. Expertise with flow cytometry, laser spectrometry, optical components, sensing. We also have Raman, that's included there, and hardware and software expertise. The laser spectrometry is just one photo for the, you can see the light colors, but actually it's a newly designed picosecond source for irradiation is visible, ultraviolet, and 2 micro interval. Custom sources also for cancer detection. Laser spectrometry lab, some results that from these sources. We have the RGB confocal imaging on red neural cells using customized continuous source with simultaneous emission. For all 3 citation wavelengths. You can see on the A side the 3 colors and the mapping of the characteristics of the cells. And on the other side, on the right side, you can see the indication of the types of the parts being trying to be detected and understand by using different wavelengths to recognize them. It's a collaboration with other partners. Swansea, Polytechnic Milan, IPG, and so. Another result was been using to detect the Fusion BI1. Compass is also using customized continuum source to continuum detection. That is some of the characteristic detection over the time, and the image spectrum of them with short and longer pulses, and the image obtained from this experiment. The other lab is a CNHH lab facility. It's a large building where we have several labs there, divided between optics, electronics, manufacturing, and biology and imaging. There the facilities are quite large in terms of optics, spectroscopy, time resolving lasers, parametric amplifier, optical components, optoelectronics, and biological analysis. The electronics also have the semiconductor part is on creating control design system, medical device. Manufacturing, also printing facilities very much used for sensing or trying to customize or reduce the cost and the size of the sensing is doing by this manufacturing process. The biology and imaging, we have molecular biology in real time, tissue culture, including isolated lab and culture primary tissues, microbiology, we have experts on that that collaborate very close with us from engineering and physics department, tissue engineering, regenerative medicine, stereo-image suites with these equipments, high output, image stream flow, device confocal microscope, and combined and nano research. Another activity also doing is the telemedicine, developing a small, compact, portable sensing device, monitor device. One is developing image processing using Android, for example, as mobile phone, processing the images of cells, changing the characteristics, highlighting parts, as an example on the left side. The other is creating body design using wireless communication with a mobile phone. So it's a prototype of that. The other is to reduce the energy consumption and portability. The other is detection of cancer, melanoma detection using an app where you study the image, filter the signal processing of the image. One of the issues, reduce the hairs. You can see the image, you have to reduce that to be able to recognize the shape and the different texture on the melanoma. So there was designed software for that. I think that you will be welcome, everyone, to come if you have any questions to Swansea for the workshop on 25th of February.